Hello, 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 welcome to the first JaCoV webinar in 2023. Glad to be here, glad that you all with us. My name is Roman, I am a host of this webinar and driver of JaCoVCommunity. Welcome everyone. So we start again our webinars and I hope they will be more often than previous year. Unfortunately, previous year was not very good for most of us, but still we're here. Webinars are back in 2023. We will try our best to make them for you and bring them for you and bring a lot of knowledge, a lot of good, great, useful stuff about Java, around Java for you, because we really feel that it's important to share knowledge with all of you, and this is what we are doing. I want to remind you that not so long ago in December we had a Java On conference, and it happened here on our YouTube channel, JaCoV. So you may just go around here and see, and you will see the recordings from our conference. So it's there. It's there waiting for you. We have a recording from the broadcast. It's just there. You may go and watch them. And also each week on Thursdays, basically today, we publish new video from yet another talk from our conference to our YouTube channel. Today we published the video from Oleg Klimenko regarding big data, Apache Spark, and how to deal with that in Java world. So if you missed this talk on the conference, you may go and see it. Already there, a talk from Mitya Alexandrov about Project Loom and how they bring it into Helidon project, comparison between Loom and Reactive and how you can deal with that. It's also there, you can watch it. And also there is a talk from Oscar Camacho regarding annotations in Java. So it's already published on Java channel and more videos will come each Thursday. Don't miss it. You may click on button to subscribe not to miss that, and you will receive a notification regarding our videos. Also, you may click subscribe button for our channel. You may click for notifications button not to miss information about our webinars. And in the description, you may find a link to our We Are community page where all our events are being published, and you may find all information about it there. If you subscribe for our community, you will not miss any of our webinars, and we will be glad to see you there. Also, we have some nice articles there and other good stuff which could be really useful and helpful for you. Okay, so I'm talking a bit because of course everyone just receiving notifications and now they are running to reach our webinar, but to stop some talking, let me invite here our speaker. Our speaker today is Semyon Levin. Semyon, hello, welcome to JaCoV webinars.
Hello.
Hello, nice to see you here. Do I remember right that currently you are in sunny California?
Yeah, I am.
So
It's
hello
really
to
sunny here and warm. So yeah, the weather is really beautiful as usual here, basically.
Okay, so hello to sunny California from sunny Malaga.
Yeah.
Okay, guys, so just for you not to be jealous, it's freezing cold here in Malaga. In the night it's +5 and we don't have heating in the houses, so you not to be jealous for us. So I'm in some in some hoodie just to not freeze while we're delivering you information. Yeah, Semyon as well. Still winter. Okay, so yeah, Semyon, can you tell us just a couple of words what your talk would be about?
So my talk will be about a project that I was working on. It was an internal EPAM project for EPAM interview portal. So basically, we had to build a new service from scratch that was responsible for handle all interviewers as like interviewer entity with search, with a lot of integrations with different EPAM systems. There were a lot of them, and it was fun, really fun, I would say. We were given a lot
Nice.
of freedom in terms of development. Our management gave us, I would say, plenty of time to improve our technical processes, improve our code base, and so on, to eliminate tech debt. So basically, we could do whatever we want. I would say it this way. So it was really fun. It was very challenging, I would say, because all the technical things that we did were not like for newcomers, I'd say, because we had to overcome a lot of challenges to make the code looks pretty, I would say.
Nice to hear that. So I hope you will share some insights from internal development projects with our audience. So guys, we will just dive into the talk right into the minutes. I just want to remind you. So basically, we have two chats which I will monitor. I will try my best to catch all the questions you will post there. So first one is on YouTube. So on YouTube, you have a chat. You may post the questions there. I will see them, and if you will post it there, I will have ability to even push it to the screen, so everyone will see these questions. This is first option. Second option is we are a community platform, so there is also a chat, and I also monitor it. So you may post the questions to either platform you want. I will get all the questions and try to ask them to Semyon. So please write the questions there during the talk, and in the end we will have time for answer your questions. So saying that, like, I'm thrilled. I'm really thrilled to start the first webinar in 2023. I think it's time. So Semyon, good luck. Good luck with your talk. Let me share your screen. Yes, it's here. So guys, good luck to all of us and have a good watching. Let's go.
Okay, so today we'll be talking about how we build enterprise expert search system. In EPAM, what challenges we had to overcome, and yes, to build the system, we had to integrate with 15 different data sources, or probably even more than 15. So a short disclaimer, so everything here is my personal opinion, which doesn't represent opinions of any company, and is for informational purposes only, and so on and so on. Okay, so the project I'll be speaking about today is EPAM interview platform, and EPAM is constantly hiring a lot of people, so this platform is really important for EPAM business. And I led the development of interviewer service. It was a completely new service for this platform, and it was responsible for interviewer subdomain. So our goal was to collect all the interviewers into one service, provide flexible search, a lot of integrations, and so on and so on. So a few words about the project itself. So what is interviewer in a PAM? So basically any PAM employee can interview. So we had to handle all employees. Interviewer has personal information, obviously, rating. Yeah, we have rating for interviewers. Also skills. We don't want, I don't know, a .NET developer to interview Java developer. Certifications. EPAM gives a lot of learning opportunities, but here in this project, we are interested in certified interviewers. Working schedule. Of course, when we schedule interview, we want to know interviewer schedule to schedule an interview into a free time slot. Interview can be a mentor for another interview, and actually much more information. So the requirements we had. So basically, we had to aggregate data from multiple data sources. We had to implement flexible search capability. Our goal was to support up to 250,000 interviews. I mentioned consistency. Yeah, the aggregation could have a delay, and it was absolutely okay for us. Maintainability and extensibility were very important because the system evolves. We had to process personal data according to different regulations, like GDPR, and Agile development. Our process was quite close to Kanban. It was not like Kanban from the books, but still quite close to it. Technologies we had Java, Kafka, PostgreSQL, Spring Boot, Juke, and Mapstract. These are the main technologies, and you'll see later how we use them. So how does typical integration pattern looks in EPAM? EPAM has a lot of internal and external services, and obviously there are many integrations with. But most common use Kafka, and it looks like this. We have two services, service A and service B, and they're pretty independent. And when a user initiates a change in data of service A, its backend updates data in its databases and produces an event to Kafka. And then another service, in our case service B, consumes such events and changes its own data. And another user interacts with service B. So basically here Kafka performs like a data hub or events hub. And data in Kafka can look like this. For example, personal information. As you can see here, we have a person ID, first name, last name, email, different relations like location ID, like job function ID, and so on. Also, we can have interviewer rating. I mentioned it. So a message about interviewer rating can look like this. It has person ID, so relation to specific person, and value. Another example I would like to show you is about certifications. So a certified interviewer means that the person successfully completed some specific training. So to know that a person is a certified interviewer, we have to consume information about trainings and participation in that trainings. And this information is presented in two topics. One of the topics has participation information, like relation to person and relation to training and some status. And another topic has information about trainings. This information can have training ID, training title, type, and many other fields. So basically here we're interested in trainings of specific type. So yeah, let's see how we implemented it. As you remember, we used an Agile approach. It means we wrote some MVP solution and then added more and more functionality. So the very first implementation was very simple. We just consumed from a topic where personal information is stored and wrote this information to interviewer table, like this. As you can see, we process messages and write these messages to interviewer table. And then we added another consumer that consumed interviewer ratings. And this information is stored in another topic. So we implemented this consumer and added another column. As you can see, there is an additional column, rating, in our interviewer table. So we consume information about first interviewer, then about second, about third. Then we consume interviewer ratings and store them. And we don't have rating for the third interviewer, so basically we have null there. Looks quite simple, right? Unfortunately, no, it's not simple at all, because Kafka doesn't guarantee ordering on the topic level. And on top of that, our consumers work in parallel. So we can consume messages in like any order. For example, we consume information about first interviewer, then we consume information about his rating, then we consume information about rating of some other interviewer. And what should we do with it? Yes, we have a person ID, we have rating, but we don't have first, last name, email, and a lot of other columns in our database. So what should we do? Should we have nulls there? In this case, we have to exclude information from search or some other solution. It's not clear at all. I mean, it's possible to live with this solution, but it will require a lot of work to overcome a lot of different minor technical problems. So we tried to find a solution, and we discussed this one. For example, we discussed pausing consumers. And the idea was like that. So basically, we have two consumers. Let's post interview ratings consumer. So we consume all the information we have from person information topic. In this case, just just one person, and we just, let's say, consumed everything. In this case, we pause person information topic consumer and activate another consumer, and then we start processing information from ratings topic. We process rating of the first interviewer. Everything's fine. We store it, and then rating of some other person comes, and we don't know what to do with it. So we just throw it out. We stop processing here, and we activate personal information topic consumer again, and information about another person comes. We store it again. Then again, we processed everything, so we activate ratings consumer. We read again information about rating of the second interviewer. We can store it, and yeah, it looks like this. So, and we have another person. But it doesn't look simple, and to be honest, it doesn't look reliable. I do think we could make it work, but I don't think we could trust this solution. So fortunately, we didn't spend much time on it. Another obvious solution that we actually tried was SQL joins. As you remember, we used PostgreSQL as our database. So we started consuming personal information to personal table. As you can see, it's not interviewer anymore, it's person. We consume this information, and then we consume ratings to another table, like this, and then we have a quite simple query with join. So probably search won't be as performant as for one table, but actually it was not a problem at all because we didn't have a lot of interviews. 250,000 interviews, it's not very many. So potentially it wouldn't be an issue for us. But what about maintainability? For example, on this slide, we have 5 joins. And actually, it would be about 10 if you're talking about our particular implementation. So if we decided to continue with this solution, probably our queries would look quite complex. And moreover, we have many-to-many relations. For example, skills. So maintainability was not the only problem here. Yes, it's a very common problem, and there are a lot of known solutions, and they're quite easy to use, but all of them increase complexity, and we didn't want it. But before going to like a solution to all of these problems, we tried another one. We tried views. So basically, we just created a view with all of our one-to-one relations. Yeah, we just hid all the joins behind this view, and it was much easier to use. But basically, this view has all the same problems as joins. Now, probably it's just a little bit easier to use. So we had to think differently. We just realized that it became harder and harder to develop the service, and we had to find another solution. So we could try using special databases for event sourcing, like KSQLDB or Event StoreDB. You can open the links and learn about it. But unfortunately, this option has drawbacks. Basically, we didn't have experience using it. And these databases appeared relatively recently. So there was a high chance that we could face different undocumented issues. Um, Maintenance cost was absolutely unpredictable, and we didn't understand how exactly they worked on the level. And we even didn't know how much time we would spend learning. So basically, we just couldn't rely on them. We preferred using some pragmatic solutions instead of ultra modern. Um, so yeah, and at around that time, many people were talking about Securus Pattern. So we decided to take a closer look to this approach. And basically, this is the approach I'll be talking about today. So Securus stands for Command and Query Responsibility Segregation, and basically it means that we split update and read logic. And it looks like this. So we have some layers, and as you can see here, on the top we have update layer with comment and comment model. Also we have read layer with query model, and on this slide we have one database. But if you decide to learn more about this pattern, you could see that a lot of people recommend using even different databases. In common, CRUD does not look like this. In common, we just have an API that uses a model, and this model queries database. But for Securus, we have like completely different path um, for data flow. And this is the theory, basically. But what about practice? How did we apply it? Because we can discuss theory like a lot of time, but what about the actual solution? So we invented so-called indexer concept, and from the very high level, it looked like this. As you can see here, we have a lot of Kafka topics. We have special tables for each of the topics, and um, on step one, we consume a message. As you can see on the top in center, we have step one. And then step two, we persist this message to the topics table. Then we invoke reindex with person ID that should be reindexed. Then reindexer gets all available data from all topics tables for this particular person. Then reindexer composes interviewer object from all of the data and persists this object to some denormalized interviewer table. So it's just one table that is really easy to use. Um, it, it would be very fast to search through this table. We can add a lot of indexes and so on, and all the information is denormalized, so we don't have to use any joins for search and so on. So let's look closely at how it works. So we have our 5 steps. Let's discuss all of them like step by step. So step one, consume from personal information topic. I decided to discuss consuming personal information first. It's very simple, just consume the message. Again, let me remind you that it has person ID, some name, email, and other fields. Then we have step two, update topics table. Basically, we store the consumed message to a table, a special table that is created specifically for this particular topic. And we used a query like this to update this table. Yeah, it's really a lot of SQL code. So please look carefully at the slide, and let's analyze the query in detail together. So we have insert interclause. It's very simple, just insert data. I'm sure like almost all of us are familiar with this clause. Then we had on conflict on constraint do update clause, and it works like this. So if we try to insert data and some constraint, in this case personal p key, fails, we do not fail the query. We try to update data. Now we try to update this row, and here we just update first name, last name, email, and actually all other columns. And then a tricky part. We have where clause. So when we execute update in the PostgreSQL, the database always updates data. It doesn't matter if any of visible columns are updated or not. Still, there is a physical update because there are some hidden columns that should be updated. So we do not want it to happen. And with this where clause, we just check for every column except ID, obviously, that it has different value from what just came from the topic. And if all the data is up to date, in this case, we just, by using this clause, we just tell the PostgreSQL to do nothing. And then we have returning clause. And together with where, it works like this. So if we have anything to update, for example, we have a new interview, a new person, or our person should be updated because, I don't know, this person changes a last name, for example. In this case, all this query returns one non-empty result. And if there is nothing to update, if the information is up to date, in this case, all this insert query on the all this like huge SQL code returns an empty result. And by that, we know that we have to reindex this person, or we just have to stop processing here, and basically that's it. So we stop processing if we get an empty result. And then we have step 3, call reindexer. Actually, it's very simple. So we have a person ID, so let's pass this person ID to reindexer. And reindex will do a reindex. So step 4, as you remember, it's get all data for the person. Basically, reindexer executes SQL queries to get all available data for this particular person. And on this slide, you can see how we can get personal information, rating, skills, skills, multiple skills for this person. And you can ask, like, isn't it too many? So how many queries did we have? Actually, we didn't simply use multiple queries. For many to many relations, for example, we used JuCoV's multiset functionality. It's a very, very convenient way to handle such relations. Unfortunately, this functionality is not the talk's topic, so I wouldn't speak a lot about it. If you're interested, just open the links, read about it. It's very interesting and convenient way to handle many relations with JuCoV. So yeah, there were some optimizations. It was not just execute, I don't know, 20 SQL queries. And then we update interviewer table. And on step 5, we used the same insert and update on conflict do update approach as we discussed for updating topics table. But let's not stick here for long and see other examples. So this was about personal information. What about trainings? So as you remember, we use training information to know if a person is certified interviewer or not. And the interesting moment here is that actually we, in our algorithm, we have actually not 5 steps, we have 6. And as you can see here, we have an additional step. So let's take a look at this example closely, and you'll understand why we need this additional step. So again, the information about training looks like this. We have training ID, we have title, type, and some other stuff. Uh, um, so then we have step 2, update topics table. We already discussed it, nothing new here. And then we have our new step, get people to reindex. So after we save information about a training, we execute a query like this. So basically, we go to training requests. It's another topic about participation. We get all people that participate in this particular training, but by executing this SQL query. And then we just have a list of person IDs to reindex. So it's really important for us to know what people should be reindexed, and we just have to get the identifiers somehow, and this is how we did it. And then we called our reindexer, and then it got all the data and updated into your table. So from the high level, reindexer concept looks like this. Okay, let's discuss what Securus layers we had. So in terms of layers, our Kafka consumer was our command layer. Then we had our command model, and it was our indexer actually. And it updates data into your table that is stored in database. And then we have API calls that query this into your table. Basically, query and query model layers were about API calls. From testing perspective, what benefits did we get? Actually, the benefits were huge because all the layers were quite independent, and the logic was really separated. And because of that, we could easily write integration tests with Kafka instance. We used test containers for our consumers. Our indexer logic was tested with integration tests with PostgreSQL. Then search was tested by another integration test, and the API was tested by some API tests. And of course, everything that could be tested by unit tests got tested by simple unit tests. So we didn't use integration tests to test everything. But from integration test perspective, it looked like this. And the key point here is that every layer was tested separately, and we kept our tests very simple, maintainable, and fast. If it was about our abstractions, about how our components, some of our components looked like from like abstraction layer. So the first component I would like to talk about is our consumer, and actually abstract consumer. So we didn't write a new consumer from scratch for every new topic. Basically, we had a huge abstract consumer class that had different parts, let's say. So the first part is configurable consumer logic. So yes, it was in abstract consumer, and basically here we have everything related to Kafka consumption, and it could be configured but not extended. Then we have an extension point validation. So we consumed a lot of data from different topics, and we didn't want to process everything just like as it was. So we wanted to apply some small and simple validation, and here we just added validation for particular topic, and the invalid message were logged and then just ignored. Then we have another part of the abstraction, another extension point. It's mapping from every object. Actually, all of our messages are stored in error format to JuK's record. Yeah, then we had to persist this JuK record into topics table. And then we had another extension point. This is our additional step I was talking about. Basically, we had to retrieve a list of person identifiers to reindex. And then this abstract consumer just called reindexer. So basically, our consumption looked like this. And for every new topic, for every new consumer, we didn't have to write all of this. We just had to write a new implementation and add validation if it was needed, and obviously mapping and person IDs retrieval. So it was really, really easy to write an additional consumer because there were only 3 extension points. They were quite simple. And yeah, and actually we tested this abstract consumer with integration test, and all other consumers were tested by simple unit tests because everything here is covered, like persist layer, like consumption. So yeah, it's just already covered. So we don't need to write integration test for every new consumer. And on this slide, you see mapping, right? And if you remember, we use Mapstruct. Mapstruct is a nice mapper that generates code for mapping. And we benefited from it like greatly. So we wrote a script that processed our generated Mapstruct classes, and we generated our consumption documentation automatically. So what did it have? Basically, with annotations of Mapstruct, we had like every topics field. We had an information about how exactly information from every field is stored in columns of some table, and we just could generate this documentation, and it was like a fancy markdown page with all consumers, with all messages that we consumed, and how exactly these messages are stored into topics tables. Okay, and a few words about reindexing. So how exactly our reindexing process looked like. Here there was another extension point. So let's discuss it like part by part. So when reindexer is called, it created a simple, like a base JuK select query to personal information table. So basically, our personal information was like the main table for any interviewer. Then this base select query was enriched with columns from other tables. For example, rating, okay. For example, skills, multiple skills. And this step was extensible. And by that, I mean that we had a number of Spring components, and reindexer just used them. And these components just added additional columns, additional joins, additional subselects, and so on. And we used multiset a lot for that. So because of that, the end query was quite simple, I would say, in terms of understanding at least. Then we execute this query and map result to one interviewer entity or a list of entities if we process multiple people here. So we map result to interviewer entities, then we update interviewer table with these entities. and then we send notifications. So yeah, we talked today about the very high level, about theory, about testing, about some internals, and that's it. Basically, this is all I have for today. This is my contact information if you'd like to talk to me or see some of my open source projects, open the links. I'm ready to answer questions.
I will try to mimic the audience, after the talk they do like this. So I hope you all guys are applauding with me. So yeah, thank you, Semyon, very much. Thank you for your talk. I think it was great. It's a really interesting topic. I would say that we have a lot of communications in the chat. So I've tried to follow all the communications and try to answer some questions, as I was working on the similar project as Semyon, one not on the same, but the similar, and integrated with basically same data sources. So I will ask you some questions. I think we may discuss them together. Guys, just for your information, again, we have two chats, one in YouTube, one in VR community platform. I try to monitor them both, so just post your questions there or there, and we will try to discuss your questions or comments. So, first question, and basically there was a huge discussion around that, is the following. If you were able to manage Kafka topic, yeah, let me add a small comment before we start the discussion. So, guys didn't manage Kafka in this case, because Kafka was provided by another project which provided Kafka topics and data inside it. So guys here are just consuming data from these topics. But let's imagine a situation that you have Kafka in your project and you manage it. Would partitioning of Kafka help in this case? And maybe, I don't know, you investigate something around that, how this could solve the situation with different data and different topics.
I don't think so. First of all, because we had a lot of topics, and partitioning doesn't help in this case when you consume for multiple topics. So partitioning can help in terms of information on ordering for like one specific entity. For example, we have information about one person, then another message about update of this particular person, and if we store both of the messages in one partition, in this case, Kafka guarantees us some ordering. So here we can benefit from it, but in terms of consuming from like multiple topics, basically there is no like difference, and I don't think we could like improve it somehow, improve our experience of the whole integration.
Yeah, I think I may add here, maybe from my experience. So thing is that we have deal with Kafka, which throws to us a big amount of data, and we want to consume this data as fast as possible, because there are people who are using our system, or system which Semyon did, and they want this data as fast as possible. So if we will try to do this in partitioning or any other stuff, we will slow down the data consuming. So we want to consume data and then to deal with that. And also we don't want to lose this data anyhow. So that's why I think the good approach here is just to consume data anyhow you may consume it, and then try to deal with it. So solution here is with the indexer. On project where I worked, we did a bit different way. I think maybe sometimes I will make a talk about it as well. But still, thing is, like I want to add here, guys, if you not agree with Semyon, that could happen, or not agree with me, you may do your own talk about how exactly you should consume data from 15 different data sources, and for sure you will have a platform here, and for sure we will listen to your talk and discuss it. So be brave, come to us. Yeah, we really would be glad to see you here. So let's continue with questions.
Sorry for interruption.
Sure.
I just wanted to emphasize that we tried. So I showed only some of the approaches we tried, not like all of them. So we tried a lot actually, and we discussed a lot. And at the end, we just understood that there were too many challenges to overcome. There was a lot of complexity, huge complexity. So we could try doing something like different, but we just understood that the complexity was huge, and we just had to find some simple and reliable and pragmatic solution. And we, in our opinion, this solution was pragmatic and simple. I mean, it's not very simple, but it's still much simpler than all other solutions we discussed.
Okay. I have two next questions, which I know you will like for sure. I even can predict your reaction. So first one is, why did you decide to choose Juke and not, for example, Hibernate? And second question, it's like, let's say connected, not connected, but really close. Why did you use SQL database and not some NoSQL, for example, document one?
Okay, so Hibernate versus Juke. It's a complex topic. The main reason is that Hibernate has a lot of hidden complexity that we didn't want to work with, and we didn't work to ask ourselves like a lot of different questions, for example, about lazy, about how joins should be done, and so on, so on, so on. Also, we had a lot of like query builders. For example, for search we had a lot of different filters, and we had to compose our queries in a flexible way. Yes, you can do it in Hibernate, but it's not like a straightforward path. So in our opinion, Juke is much simpler, more maintainable, and what is more important is that you ask yourself much less questions about internals. You don't have to remember all of hidden things behind Hibernate. And in my personal opinion, Hibernate looks very simple when you look at tutorials, but when it comes to a real projects, when it comes to some particular complex queries, Hibernate doesn't perform that well. And I'm not talking about performance. I'm talking about maintainability, extensibility. I'm talking about simplicity. So these things are more important for me personally. But probably it's also possible to build such a system with Hibernate, but which we choose Juke. And another question was,
Another question was, why did you use SQL database
oh,
and not
SQL, yeah.
some non-SQL database?
I see. Yeah. Again, the same question about pragmatism. So we were very familiar with PostgreSQL. We knew how to operate with it. We knew what like DevOps, how DevOps should be done. We knew how we could test our code with integration tests and test containers with PostgreSQL. And yes, it's definitely possible to use NoSQL database. Why not? But NoSQL databases has, in my opinion, a um, higher costs in terms of operations. A lot of different questions can be asked about transactions, about atomic updates, and so on, so on. So yes, still everything is possible with them, but in our opinion, we didn't have too much data to operate, so we did not need to distribute data between like multiple servers, and also, yeah, pragmatism. So PostgreSQL is a very mature database, and if you don't need to but have like multiple servers, and you don't have huge amount of data, why not? You have uh, fixed schema, you have migrations, so you have a lot of checks, constraints, some other stuff you can benefit from. So why not?
Okay, fair enough. I understand right now that my camera is mirroring. I don't know why. That's why when I'm looking basically to you, I look in another side, so I will do like this. Now it should become better. Okay, so next question. Yeah, so you mentioned integration tests, and that's basically good. Question is, did you measure the coverage?
Yeah, we did. So we measure unit test coverage and integration test coverage, like all the combination of them gave us about 80% of coverage. But to be honest, it was not very important for us. And like a lot of times, I told my colleagues not to write like additional tests for fail scenarios, for example, because yeah, we just had, I would say, in my opinion, too many tests. But yeah, the whole coverage was really huge, about 80%.
Okay, thanks for answer. Yeah, there is a small question. Were all 15 data sources Kafka topics? Well, I suppose the answer is obvious, yes.
Yes, it could be different. Some of the services we had to integrate with have different integration ways. For example, REST API and Kafka. But as we decided to use Kafka, in this case, it was much easier to use Kafka like for everything. Because in this case, you have like the same implementation, very similar implementation. It's much easier to maintain. It's much easier to test. It's much easier to write only one set of abstractions and so on. And if we had to write an integration with REST API, in this case, we'll have to add, I don't know, a lot of new code that we had to maintain, and we didn't want it. So we decided to integrate with Kafka as much as possible. Yeah, we had another integration with Microsoft Outlook calendar. Like it's completely another topic. It's not a part of this particular talk, but yeah, Kafka was not the only integration for us, but I would say that the main one.
Okay, cool. Yeah, I will skip some questions as they are diving really deep in this in the topic. We have a really good commenter. It's Alexander. I may just mention it. That like really cool questions. I really will encourage you, Alexander, to write to Semyon in direct messages, and you may discuss like details about Kafka and all of these implementations, because really good comments. I'm afraid we won't have time to cover them all. So, question from Igor. As of reindex during consuming trainings, for example, sorry, it's just swapped. So yeah, as of reindex during consuming trainings messages, did you reindex all employees? If he understood correctly, isn't that expensive to reindex all the employees?
Okay, so let's say we consume a very common skill like Java. And so if you remember, for some many-to-many relations, we try to get like all the people that should be reindexed and reindex them. So let's say we consume Java. Yeah, it's a lot. And probably in this case, it will be really expensive. It's true. But let's discuss, like, is it really a problem? Because again, our requirement was eventual consistency. So we didn't have to process everything like immediately. We could wait and we could wait. Uh, sorry, and we could spend a lot of time on processing. We could optimize it, and we had a lot of discussions about optimizations, about ways to make it faster. But at that particular point of development and that particular stage, we just decided that it wasn't needed, it wasn't required, and we could live with it. Because such entities like Java skill mostly it will be processed basically once. So you consume it once, and then it's really unlikely that you'll have to process it again and reindex everything again. About trainings, yes, it's another many-to-many relation, but how many participants do you have on like a training run? 10, 20, it's not much. So yes, it is expensive, but in our particular case, it was not a problem, and we decided do nothing with it. If it was a problem, in this case, we had some ideas, so I'm sure we would find a way to deal with it.
Okay, great. I just want to mention that we have two chats. I try to monitor them, and I see questions in both of them, so it's not needed to duplicate. I just try to make a original queue of questions which comes to ask them. So the question from Vladimir. Thanks, Evan, for sharing such useful experience. Why reindexer didn't use a single select with joins and sending the normalized data directly to resulting table?
Actually, Indexer did use a single select, but not with joins, with subselects and multiset. So again, you can learn about Juke's multiset on official Juke site. It's a very convenient functionality. So about like one-to-one relation, we could use a join. Why not? And in terms of performance, it's quite close. About many-to-many relations, we used multiset because it's much easier to map data retrieved by multiset to one specific entity than in comparison with like standard join, I would say. It's just more convenient.
Okay.
So for like it was easier for me to show you an example with multiple queries, but then I added another slide that showed that actually there were some optimizations. It was not that simple. We didn't execute 20 queries for each person. Yeah, of course. But from the very high level, it worked like that. Basically, we just got all the data for this particular person and combined it into one entity that then was stored into one table in the normalized form.
Okay. One more question regarding performance. I really like it. So did you consider performance difference between calling reindexer on every consumed message as it was implemented, as you showed it, or and versus calling it periodically or in batches of changes? Let's say every 100 messages consumed or every 5 minutes, something like that.
Yes, again, it was not so simple. We did call it in batches. So our abstract consumer batched all the messages. Then we retrieved people to reindex like in batches, and actually we could have like 100 people to reindex. But again, it's a very deep internal topic. We could like talk a lot about it. I wanted just to show you the concept, not like implementation. But yes, we not only considered doing it, optimizing it, but we also implemented optimizations. So we batched our messages. We consumed it like in batches of 100, and then we executed reindexer with a list of people to reindex. As you could see, there was a list there. So yeah, it's a good question. Thank you.
Okay, cool. And I think the last question. So sorry guys, a lot of questions here. I couldn't ask them all, so I tried to choose them. So last question. As you spoke about Juke, like obviously we have a question regarding Juke. So did you use the open source edition of Juke? And if yes, did it have enough capabilities, or did you lack some features of the paid version?
It was an open source version, definitely. It was absolutely enough for us. We used code generation, of course, of Juke, and yeah, the open source version, and it was enough.
Okay, thank you. So guys, that's basically it for this webinar. First of all, Semyon, thank you very much for your webinar. Really interesting topic, really, I suppose, useful one. So guys, please do virtual applauses for our speaker. He opens our webinars for 2023. Thank you very much. Couldn't mention that our, let's say, friendship with Semyon started with a really toxic comment from him in feedbacks when he said that, like, hey guys, well, your webinar is good, but I know how to do it better. And then we call him and say, like, hey, could you do it? So that's how we started. That's how we start our communication, and that's really cool. So why I'm saying that? We have a feedback form, and we really read it, and we really want you to leave all the comments you can leave there, positive, negative, whatever. We really try to make our webinars better, and thank you for doing this, and please spend a couple of minutes to do so. We would really hope to see some of your comments in feedback form. Also, you may DM me, for example, if you don't want to put it in feedback form. Of course, I will be glad to see your feedback. Also, we're always looking for speakers. If you have some topic you want to tell us how to do it in Kafka differently and with Kafka differently, feel free to reach me. We will discuss it with you. And for sure, your topic would be on our webinars. That's basically it. That's basically it for first webinar of JaCoV. Stay tuned. Subscribe to our channel, subscribe to our community page. Stay with us. JaCoV Webinars is back for 2023. Semyon, thanks again for starting this year.
Thank you for the opportunity.
Great to have you all the time. So my name is Roma. I'm a driver of JaCoVCommunity. Nice to be the host here. Thank you very much, and see you next webinars. Bye, guys.